All right, so here we go. Example number 1. A new car costs $25,000. The value of the car decreases by 15% each year. When will the car be worth $8,000? Okay, first we got to figure out which formula is it. Now, it's not saying anything about interest being earned on an account, so it's not Formula 1 or Formula 2. And what I see here is we're talking about the value of a car. So value of a car indicates that it's probably going to be the last thing. So we're actually going to use Formula 4, which is V sub n equals P parentheses 1 plus or minus r to the nth power. So off to the side, my recommendation is list all your variables, V sub n, P, r, and n. Okay. And now we want to go back and reread the problem and try to figure out what are these quantities. Now, because there's 4 variables, we're going to know 3 out of the 4. We'll only ever have 1 missing value, okay? So a new car costs $25,000. That's the starting value. So that's the principal value, or P, $25,000, okay? The value of the car decreases by 15%, okay? So that's a rate, 15%, which is 0.15 in decimal format. All right, and then it says, when will the car be worth $8,000? That's the amount of money that we want to end up with after a period of time. That's the value of the car that we're looking for. So n, the number of years, when. When is what we're solving for. Okay, so we're going to start plugging in everything that we know. So we have 8,000 in place of V sub n. We have 25,000 in place of the P. Then we're going to have 1 we're going to subtract because we are decreasing in value. So the rate is 0.15 per year, and then the number of years is what we don't know. Now we need to solve this equation. So we now have an exponential equation to solve. Now this will be slightly easier if I make this say 8,000 equals 25,000 times, make this base 0.85 by doing the subtraction. We want the exponential to be by itself, so we want to divide out the 25,000. Divide out the 25,000. Now, when we do 8,000 divided by 25,000, we can leave that as 8 over 25. Or in this case, it comes out to a nice decimal. This is 0.32. So I can use either the fraction form or the decimal form, whichever you're more comfortable with. Does not matter which one you go with. So now I have an exponential equal to a number. Now I'm going to focus on the decimal version of this. All right, so now I need to either convert to log form or simply take the logarithm of both sides and then solve from there. Then I won't have to do the change of base formula. So now I'm going to have log of 0.32 is equal to, I can bring the exponent down and multiply it by the log of 0.85. So then to get n, I want to divide. So n is going to be equal to the log of 0.32 divided by the log of 0.85. Remember, there's parentheses here and here when I go to do this on the calculator. And when I do that, I come up with 7.011. Now, we're going to round to 3 decimal places unless we're told to do otherwise or there's an implied rounding involved. We'll talk about that in a little bit, okay? So I started with words, I need to end with words. So my final answer here, it said, when will the car be worth $8,000? So the car will be worth $8,000 in approximately, and I'm going to say 7 years here. I'm going to round to a whole number because it's realistic to do so. I could keep it as 7.011, and that would be fine, but I don't have to. Getting the word approximately or about or roughly, those qualifying words make it okay to round, but we want to be careful when to round and when not to round. And we'll kind of talk through it as we go through the different examples. Okay. So there's problem number 1. All right, let's talk about problem number 2. Suppose you deposited $500 in a savings account that pays 8% interest compounded continuously. Now, there's a key phrase, compounded continuously. That implies right then and there, interest compounded continuously is formula number 2, A equals PE to the RT, okay? Which means I must know A, P. Keep in mind, E is not a variable, it's a number. These are the things that I should know. I should know 3 out of the 4, okay? So let's go back and read it again. Suppose you deposited $500. So that's the starting balance in the account. That's the P value, the principal or starting initial value. it pays 8% interest. Okay, so the rate is 8%, which is 0.08. Okay. And then that was everything that was given to us in the original description. Part A says, how much will the account be worth in 7 years? So T is 7 years, which means the ending amount is what I'm looking for. Okay, so I do A equals P 500, the number E to the R 0.08 times T 7. And now I just need to type this into a calculator to get a final answer. So I'm going to end up getting that this is 875, I believe 0.34. Okay. Now, why am I only going to 2 decimal places here? Well, I'm going to 2 decimal places because we're talking about money, and money is always dollars and cents. So it doesn't make sense to carry 3 decimals here because we're talking about money. So anything that has a monetary value at the end, we're always going to go to 2 decimal places to make it have context, dollars and cents, okay? Now, if you run into any issues with typing things into your calculator, if you have it written on your paper on a test, you can bring it up to me and I can help you double check to make sure you're typing in the calculator right, okay? So my sentence here, to go with the word problem, is the account will have $875.34 after 7 years. Now, in the real world, if you open a bank account, you're not going to let it just sit there for 7 years and not do anything with it. It would actually go dormant, and then the bank would end up closing the account on you and send you a check for the balance that was in there, okay? But this is a very simplistic form of how exponential functions work in the context of banking especially. It gets much more complicated, but this is something that they would actually use when it comes to calculating interest. It just gets more complicated because you make multiple deposits over this period of time that you're talking about. So it would go up faster, realistically, unless you were withdrawing money. All right, part B here, when will the account double its value? So now I'm gonna make the same list. All right, when will it double its value? So the principal value is still 500 and the interest rate is still 8%. But now I don't know when. I'm looking for when. So time is my unknown, but the account's gonna double its value. So that means I'm really gonna have $1,000 in the account now. Now, realistically, we know it's gonna have to be more than 7 years because in 7 years it went up to 875, so we're not at the 1,000 yet. So our answer has to come out to be bigger than 7. So now I'm gonna write the equation 1,000 for A equals P 500, E to the R 0.08, T is unknown, all right? So now, again, I have an exponential equation. I want to get the exponential part by itself, so I'm going to divide out the 500, divide out the 500. And that's going to give me 2 is equal to E to the 0.08t. Now, I want to take the log of both sides, but because there's a base of E, I want to take the natural log, because the natural log is going to end up canceling off the E part of it and just give me the exponent on the right-hand side. So it'll make it a little bit easier, and I won't have to use the change of base formula. So this is now simply 0.08t. So to get t by itself, I'm going to do the natural log of 2 divided by 0.08. Okay, and that's going to give me that t comes out to, let me just double check my number here, natural log of 2 divided by 0.08 comes out to 8.664, and that's measured in years, which is more than the 7 that we got in part A, so we have a realistic answer here, all right? So as far as the final answer goes, I'm going to say the account doubles its value. Whoops, the account will double its value in about 8.664 years. Now, because I put the word about in there, I could round this and say maybe about 8.7 years or 8.66 years. I could round it a little bit differently. The important thing is I can keep it in terms of years. I do not need to convert this into years and months, okay? All right, so there are the first 2 examples. I'll make a separate video for the others, all right? So we'll do like 2 at a time. All right, see you in the next one.